Hi guys, and welcome to episode 3 in our mini-series called Trig Substitution. In the first episode, we went over just an introduction on how these came to be. We really focused on 1, and what we did was we just had a general equation, and then we showed where each of these sides would come from, and we talked about the derivation of u equals a sine of theta, and therefore the square root of a squared minus u squared was a cosine of theta. So we talked about that all in our introduction. And then I challenged you to figure out these other 2 triangles. In episode 1, we went through an example that specifically worked with this first rule here. So in this episode, we're going to work on another rule. So we're going to find the integral of dx over the square root of 4x squared plus 1. Now, remember, we know to use trig substitution when we have something that looks like it could have possibly been the Pythagorean theorem, because the Pythagorean theorem is used in right triangle trig. And in right triangle trig, we use sine, cosine, tangent, cosecant, secant, and cotangent. Now, the other thing that I like just to keep next to me at all times is this review of basic integration rules, because if I can find something on here, it makes my life a heck of a lot easier. So I'm looking at this and I've got the square root of something squared plus something squared. As I look down at 18, 19, and 20, I don't see anything in exactly that same format. And so I'm going to have to use one of these rules here. Now we're going to draw special attention to this. When we draw special attention to that, what we see is that we have some function squared plus 1. And 1 really is the same thing as 1 squared. And so this could potentially be a u squared plus a squared. So we need to figure out, are we going to use 1, 2, or 3? And because of the plus sign, we're going to use 2. There's a plus sign there. And plus means it doesn't matter if we have a squared plus u squared or u squared plus a squared. So we're going to use this triangle here to represent this problem. So go ahead and draw a right triangle. This rule says that our a squared plus u squared is going to be the hypotenuse. Now remember, the u squared piece of it is actually the part that has an x in it. And we could rewrite this right here. We could rewrite that as the square root of 2x squared plus 1 squared. And that would mean that u is 2x and that a is 1. And that's really important to know. Okay, so our hypotenuse is going to be the square root of 4x squared plus 1. The leg that is identified as u is going to be 2x because u is 2x. And the leg that's identified as a is going to be 1. Now, in episode 2, when we were going through an example using the first rule, we actually went and we rederived how we got this a cosine of theta. I'm not going to do that in this one, but if you would like to do that, I challenge you to pause this video and go back through and work that out. So in this case here, this rule tells us that we're going to say that u is a tangent of theta. We're going to say that u, and u is 2x, is a tangent of theta. Well, a is 1, so it'd be 1 times tangent of theta. And if we want to get x alone, then x equals 1/2 tangent of theta. Now, remember, what we're doing with these is we are finding a way to replace things in this equation. Well, we are going to replace all of our x's in the equation with 1/2 tangent of theta. We are going to replace the x in the equation with 1/2 tangent of theta. We need some way to replace the dx. And so let's go ahead and take the derivative of this. Dx equals, well, the derivative of tangent is going to be secant squared of theta. The derivative of tangent is going to be secant squared of theta. And so this becomes 1/2 secant squared of theta d theta. Now we would replace all of our dx's with this. We would replace all of our dx's with this. The other thing that we know is that a squared plus u squared equals a secant of theta. And so that means we can actually replace this whole denominator with just a secant of theta. So let's go ahead and do that. So this piece we actually don't need because the rule tells us what we're going to replace it with. So we actually don't need this piece except to get us what our dx is going to be. All right, so let's go ahead and rewrite this. We're going to have theta is dx, which is now 1/2 secant squared of theta d theta over, well, this tells me right here that the square root of a squared plus u squared is just a secant of theta, and a is 1, so this is just going to be secant of theta. Quick recap. This part replaced our dx. This replaced our dx. That's this. This came from this, from our rule. Now, what we did in the first episode was we actually plugged this in for x, and then we solved, and we figured out that that would turn into this, but of course we did it here for episode 1. If this piece is confusing to you, I urge you to pause the video and work through it just like we did the first one. Now comes the simplifying piece of it. So the simplifying piece of it, that 1/2 is really like this, 1/2. Secant squared of theta divided by secant of theta is just secant of theta d theta. Now we want to look over here, can we take the integral of secant of theta? And we can. The integral of secant of theta, keep that 1/2, is going to be ln of secant of u, or theta, I guess, here. Let's not confuse that. Let's not put a u there because that could be really confusing. We have a theta here, so it should be a theta here. Plus tangent of theta plus c. Okay. So we have now done the integration piece of it. But this is in terms of theta. This is in terms of theta. We started in terms of x, so we need to end in terms of x. The way to do that is to go use our triangle and figure out what is secant and what is tangent. We can replace these with whatever secant is and whatever tangent is. So let's start with secant. What are we going to replace this with? Well, secant of theta, looking at our triangle, remember secant is the reciprocal of cosine, and so secant of theta is going to be hypotenuse over adjacent, which is the square root of 4x squared plus 1 over 1. So I can replace this piece of it, I can replace that piece of it with the square root of 4x squared plus 1. Now I need to figure out, using my triangle, what is tangent, which I mean, we kind of already know what tangent is, but let's go ahead. What is tangent? And remember, tangent is opposite over adjacent, and our opposite is 2x, and our adjacent's 1. So we can replace the tangent with plus 2x. Don't forget your plus c in the end. And we have found the integral. So let's do a quick recap. We started with this equation. We had to figure out which trig integral we were going to use. Were we going to use 1, 2, or 3? After we figured out which rule we were going to use, we drew a triangle. We solved for x, and then we found our dx. And we solved for x so that we could replace the dx in the equation with the dx. We then used what it told us over here to replace the square root. We simplified, we integrated, and then we put everything back in terms of x by using our triangle. So I'm going to leave you with a problem that I want you to try on your own. As always, if you have questions, go ahead and drop them in the comments. That's supposed to be an integral symbol, sorry. And you have x cubed over the square root of x squared plus 9 dx. Good luck.